Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Idam Ashraf bin Rafi. I'm from Group 7. We will present about driven and cast in place pile, focus on Franki pile. Let's meet our group members. There's me, Muhammad Idam Ashraf bin Rafi, and my group mate, Esfahan Rifki bin Yusri. Okay, let's jump into the introduction. The Franki pile is a type of composite pile and is classified as a driven and cast-in-place pile. It is also known as a partially preformed pile because its construction combines a steel tube or the temporary casing and in-situ concrete. Unlike bore piles, Franki piles are formed by driving, not drilling. This piling system was developed to overcome problems encountered in loose soils and site with running or high groundwater conditions. About the type and the selection, Franki pile falls under the category of composite piles, where more than one material or construction method is used. It combines steel tube driving for penetration and soil displacement and cast in situ concrete to form the permanent pile. Commonly selected for medium to large construction project, sites where final pile line cannot be accurately determined in advance. Medium to large construction project means the cost is millions, not small renovation, and the duration around 6 months to 2 years or above. Next, particularly suitable where groundwater flow makes bore pile difficult or very loose soils cannot support open boreholes. The last point is used as an alternative to bore piles and fully preformed piles. Next, I will talk about the method of construction or the installation. Stage 1, driving of steel tube. Let's take a look on the picture. Number 1, set driving pipe in place. Fill in stopper, concrete and ram in. The picture show about driving pipe, free fall pile hammer, stopper made of concrete or gravel. The GW stands for groundwater, non-load bearing foundation soil, and it shows about load bearing foundation soils. The first point is a steel tube fitted with a gravel plug at its base is positioned vertically. The tube is driven into the ground using a drop hammer or heavy piling rake. The gravel plug creates friction with the surrounding soil, allowing the tube to penetrate deeper. During driving, soil is displaced and surrounding ground is compacted. Next, the second stage about the formation of enlarged toe. Take a look on the picture. Number 2, ramming in the driving pipe through inner ramming with free fall pile hammer. The picture show about pile drive into the stopper. The stopper is always water resistant, closing with stopper, and it show about penetration into the earth. Point number 1, continue hammering force the gravel plug out of the tube. This forms an enlarged base or the enlarged toe at the bottom of the pile. The enlarged toe increase end bearing capacity and improve overall pile performance. I will pass the presentation to Mr. Esfahan Rifki bin Yusri. Thank you.
Hello, Assalamualaikum. My name is Esfahan Rifki bin Yusri, and today I want to present about the method of construction or installation for the Franki pile. For this stage is stage 3. Stage 3 is concreting. In situ concrete is poured into the line shaft through a hopper or skip. Next, concrete compaction is achieved by impact from an internal drop hammer or vibration the steel tube as it is withdrawn. The steel tube may be completely removed or partially withdrawn depending on design requirements. For the method of construction or installation, stage 4, reinforcement. As we can see in the sketch, the first one is to set driving pipe in place, fill in stopper concrete and ram in. The second one is ramming in the driving pipe through inner ramming with free fall pile hammer. Number 3 is formation of the pile base through ramming down the concrete. As you can see, the pulling during base formation, it's refilling the concrete to the ramming down to the base. And number 4 is fitting the reinforced cage and concreting the shaft, pulling the driving pipe and refilling concrete to fitting the reinforcing cage. For the last one is capping the pile head, arranging the connecting reinforcement. The pile is finished and after hardening, ready to bear loads. And to make it simple, I make it point by point in the right side. And the first one is a reinforcement cage is inserted into the fresh concrete. The second one is the main reinforcement bar are left projecting above the ground level. And the third one, to projecting the bar allow proper connection to the pile cap. And the last one is the final product. It's a fully formed in situ reinforced concrete pile. Okay. The advantages for the Franki pile is a lot. For the first one is suitable for very loose soils and groundwater condition. The second one is produces high load bearing capacity. The third one is formation of an enlarged toe improves and bearing resistance. The third one is soil displacement during driving results. It improves soil density and it gives a better shaft resistance. And the next one, the final pile length can be adjusted on site. And the last one is no open excavation, reducing the risk of bore collapse. For the disadvantages is requires heavy piling equipment and rigs. It generates high noise and vibration, making it unsuitable for urban areas or noise sensitive location. Next is require a large open and level site. Construction quality depends heavily on workmanship. The last one is the risk of necking, which occurs when groundwater washes away fresh concrete, it reducing the effective pile diameter and decreasing concrete cover to reinforcement. In order to construct Franki pile, we need to have the plan and equipment. For Franki pile equipment, it usually be using a heavy duty piling rig. The second one is drop hammer or vibrating hammer. And the third one is steel tube for temporary casing. The fourth one is hopper or scape for concrete placement. And next, crane and winch system. And for the last one, for the Franki pile plan and equipment is concrete compaction and vibration equipment. The conclusion for the Franki pile is the Franki pile is a robust, driven and cast in place piling system. It is especially effective in difficult ground conditions where bore piles are unsuitable. Although it offers high performance and adaptability, it requires heavy machinery, skill operation and carefully quality control. And the last one is proper planning and site selection are essential for successful implementation. That's all from us. Thank you.